Welcome to this session about running extremely large HANA databases in public clouds. I guess to begin with, I'm curious to know how large of, I assume everyone in here is interested in running a database if you're not already, and also in a public cloud. So how large a HANA databases are you guys running? So let me say, anyone running over a terabyte database, okay? How about 5 terabytes? Okay, 10? Okay, 20 terabytes. Oh, wow, okay, 20 terabytes. Okay, all right. So 25 terabytes? 25, okay, how big's yours?
Yeah, 25, that's the limit.
Okay, 25. All right, so those of you that have run large databases, you might have already had to go down some of these roads and learn some of these things that I did. So I'm a premium support engineer and dedicated to a customer, and their database is about 24 terabytes right now. So we want to talk about what makes a very large or extremely large HANA database. It seems like almost any HANA database is pretty large, right? And so we're going to talk about what that means, what qualifies it, what are the issues that arise with that, and also what guidelines should we follow when we're doing this. So one of the things to understand, I guess, SUSE's role in all of this is we, as the operating system, for these instances, look to optimize it, right, and to manage it from an OS level. But as far as the certification, the number of SAPs, that's all certified by the platform, right, whether it's a hardware or a cloud platform. And so we can, for example, go look and see what is certified for our instances in Azure from their website. Now, when we go to SAP, here's just kind of a screenshot I took. We can see that we've got some from Amazon and Azure. We've got from Google. And when we look at this, right, we're looking at different types of memory sizes, what role they are, whether it's for HANA or an application stack. And then we're looking at number of cores. So probably you've visited this website and are familiar with it. But to understand, what do we need to run? Now, just diving a little bit deeper, looking at what is available. Here's a couple that I pulled. If we take a look here, we're looking at this S896OM. We're seeing, it's looking at less 12 SP1 on there, up to 15 SP1. And we see here it's a bare metal instance. Where we look at this other instance over here, now, and we also looked at 24 terabytes, 896 logical CPUs. Here we're looking at 832 logical CPUs. But a couple of things I want to point out as you're planning a large implementation is to understand: do you want to go bare metal or do you want to go with the large instance? And in this case, when we go with this instance, notice that the SP levels that are supported are a little bit more limited, probably because it's newer. That's usually what you'll see as these grow, as well as kernel versions. So when we talk about a large system, one of the things that makes it unique is the actual system designer, the system board. If we look at just kind of starting at a baseline of a single socket. One socket, let's say it's got 26 cores. If we do an LS CPU, it's going to report 52. If it does, then we know we have hyper-threading enabled. And I'm going to talk a little bit more about hyper-threading with HANA and its supportability and what we get from it as well. But in this case, we see that there's one NUMA node. And so when we talk about NUMA, we're talking about the non-uniform memory access. And basically, we're at its simplest term, we're just saying what is the memory off of this CPU or this memory controller? And so in this case, we would have, 52 logical CPUs that would be available to us to utilize for our implementation. Now, when we look at something like this, really, even though it says NUMA, a non-uniform, it actually, with one socket, it will say it is uniform memory, right? We have one address space that we're dealing with. And so if you were to, for example, when I run this on my laptop, it does show one NUMA node on there because I have one socket. Now, when we start getting to multi-socket systems, right, and I'm only showing 4 here, but if we're looking at 8 or 16, right, something that's going to be on the high end, now we have to look at things a little bit differently. So first of all, we need to recognize that we have these interconnects. So they're either sometimes depend on the technology, quick path internet interconnects, but how are those processors going to talk to each other? We don't typically, like when we had one NUMA node, we had one socket and all the memory off it. Now we have memory off of every socket. Okay, so now when we look at our LS CPU, we're still looking at our number of cores, for example. We do have hyper-threading enabled, and there's our actual cores in our sockets. So we times all that, we should get our 832. Further down on our listing, we'll see that we have different NUMA nodes. So each one of these sockets is referred to as a NUMA node because each one of them has its own memory space. And when we start talking about large systems, we need to start thinking about this because in some ways NUMA solves the problem of we can have more memory, right? It also allows us, when we're loading a large database, that we'll have less contention, right? Because now we only have, or we should, only have, the 52 virtual CPUs that will be accessing this memory. But what's the problem with that? Anyone know? The problem is if this core, let's say core 34 over here, needs to access memory over here, okay? Now, we're still probably talking nanoseconds, so maybe usually you'll see something like on Intel's website like, hey, if this CPU has to access this memory, it can probably do it, 9 or 10 nanoseconds. If this core has to access something over here, we're going from a factor of like 9 nanoseconds to maybe 150 to 200, okay? So we're still pretty fast, but we are going to have some latency just because we have to go across this quick path interconnect of those. Now, most of the time, we're looking at like a 8 or 16 socket board, so they're going to be pretty close, but there are some situations where those actually could be separate units, and actually have separate cables for that to happen. All right, so rather than talk completely about that, why are we caring about this? Well, first we need to understand this is because how does the Linux kernel play into this? Well, when the Linux kernel is looking for scheduling, and this happens at typically an interrupt, right? So we're getting all these interrupts, and a processor needs to get scheduled, and it needs to access some memory. Well, what happens is when that gets on that processor, and it says, okay, I need to access some memory. Well, if that memory, let's say that this NUMA node is full. Well, if it's full, then it's going to have to go to one of those other nodes, okay? So and that's going to happen, that's going to cause what we call a NUMA miss, okay? At the same time that NUMA miss, it will record a NUMA foreign in that node where it wasn't able to get memory, okay? If it was able to get that, then we get a NUMA hit. And so you can see that trying to access this non-uniform memory can be a little more overhead when we are talking about these large systems. Now, when the system loads, the ACPI loads what's called a locality table, okay? And this locality table, we'll see that by running a NUMA control hardware on there, and you'll see a matrix like this. So for example, the way this reads is node 0, if it was going to talk to node 0, has 10. And it goes up to 256. And the easiest way to interpret this, and I don't know why it's done this way, but just move the decimal over 1. Okay? So if you say it's a factor of 1, so there's no overhead. Okay? Now, if we take a look at 0 had to talk to NUMA node 1, it's a 1.6. That's why I say. So if it said 256, then it would be a 25 times slower access that NUMA node. And so that's why I highlighted all the way down here, is because each one of these, to access where it is, its current node, is just a factor of 1, right? It is what it is. Now, a couple things to understand is the Linux kernel itself, if it has a factor of 30 or more, will not try to reclaim, meaning try to move that over to where it's being executed. And that's also going to be only enabled when node reclaim mode is enabled. Otherwise, it will keep it to where it is. Now, why are we talking about this? Well, the first thing to understand is that HANA is NUMA aware, and it will manage this for us. And so a lot of these settings that we need to take a look at, so for example, NUMA balancing disabled, we don't want the kernel doing that. HANA is going to take care of that for us. When we use SAPTune and apply the HANA solution for that, it will set that for us. And so we'll see that on the grub command line when the system loads. But there might be some things that need to happen manually, and that would be in our global configuration to make a reloading of tables aware for that. Now, one of the things I skipped over on here is the what issues might arise, and how do I know if I have issues? Well, some of the indicators are first, when we look at our NUMA, and I'll talk about that in a moment, when we look at our NUMA utilization, do we see high CPU utilization on some NUMA nodes and not on others? So HANA should be able to be balancing that out. Now, as you know, not everything's just cut and dry with HANA, right? And these systems, it depends on the workloads that you're running there, whether you're going to see that or not. However, if you do see that, high and low, great disparities, then there might be things you need to do, and there's some SAP notes that will help you with that. Also, a large number of threads, so that the workload is not being distributed across the different NUMA nodes. Those would be some indications that some tuning needs to happen. Well, we can look at those things by using the NUMA stat on there. Anyone used NUMA stat before? Okay. So one of the things to know about this is you're looking at NUMA hits and misses, but you're not necessarily looking at bandwidth, right? You're not looking at latency, some of those other things that we're interested in, and I'm going to talk about those in a minute. But what it does show you is, am I getting a lot of hits? So for example, if I was getting a lot of hits, but for some reason one node was very low on there, then I might need to look at that further and see why is that. And there's some tuning options. I can do both at the HANA level as well as at the OS level for that to operate more effectively. But I just wanted to point this out, that sometimes these numbers are actually just kernel counters is what it's reading. So you're not going to be like adding extra monitoring overhead when you're looking at this. You can run this and take a look at what this looks like. And I would suggest that you do it to get a baseline of your environment. so that when utilization or when heavy workloads happen, that you can take a look at that. Some other things that we do that are related to NUMA is NUMA IRQ pinning. So going back to our workloads, when we were looking at these interconnects, the actual architecture of the system board does make a difference. So for example, I know some systems I've worked with, the NIC is actually off of NUMA node 0. On some other systems, the NIC is off NUMA node 1. Well, the reason why I care is because when that IRQ happens, when that interrupt gets made, if IRQ 24 makes a request into the kernel typically says, okay, well, which CPU is available that I can put this workload on there? Well, I want to know what IRQ my NIC is using, okay? Because if it's attached to NUMA node 0, I want to pin it to NUMA node 0 so that the kernel always, when it gets interrupt 24, it will keep it on node 0, which would be a range of processors. Like looking at my example, that would be like, maybe up to 51. But when I do this, when I start pinning, now what I'm doing is I'm saying, okay, I understand my workload enough that I'm going to tune it. By default, the kernel is going to do this. And so you actually have a service called IRQ balance. And so when you do this, you're going to disable this. Now, unless you understand the workload, do not disable this service. The SUSE documentation even tells you that. However, when you do something like this, and I'm not saying this will work for every time, but in my experience, you may get, by just pinning the network on here, you might get maybe a 20% bump in performance. Especially if you're looking at, your NFS mounts and those types of things, right? Now, we had some situations where we didn't get it. And also we had multiple NICs and we had accelerated networking, right, in the cloud. And so there were lots of factors, and we actually had to pin things there. Now, when you're doing this, for example, when we did this in Azure, we followed this TID, and this talks about it, and there's some Mellanox utilities that actually that help you identify what are the IRQ. But you do need to work with the cloud provider to find out which node that NIC is off, and or which node it's connected to. And this typically will be advantageous if you are using accelerated networking, which I assume in a HANA environment you would be. All right. Now, as far as also on large systems, when you're looking at over 800 CPUs or 400 CPUs, whatever, I mean, those are still both very large systems. We want to take a look at, well, what are these CPUs doing when they're not being utilized, right? It might be a lower utilization until, a big job happens. And so when we look at this, understanding our processor state. So when we look at our C state, so C state 0 means executing. That CPU is in executing mode. And so anything that's above, and both of these states work the same, anything that's above, the higher the number, the deeper the sleep of there, okay? And so for a C state, we're going to keep I'm just going to focus for our discussion on that it's executing. Now, once it's executing, we want to look at the performance state on there. And so typically the SAP notes will say set this to 1, which means that we have a guaranteed. Once again, it determines how deep a sleep that is, or we're going to wake it up from. So the reason I bring that up is because, for example, if you go greater than 1, now you're going to get into like turbo modes, which a lot of times we think, well, turbo mode's good, right? It's going to overclock my CPU. And that sounds like a good thing. I'll get more out of it. Except for it's not. Because when you've got a lot of cores on a CPU, what it does is it says, I'm going to let these ones leave these cores in a lower power, and I'm going to clock up these other cores. Well, guess what? Your workload might need those other cores, and now it's going to take longer for those to be brought up into higher performance. And so what you want to do is typically you'll set these to 1. And once again, there's SAP notes on here. I've got some links on here when I provide the presentation. But basically also you want to look at just setting the governor for the CPU to performance for that to remain. You will see a little bit of fluctuation maybe in your CPU frequency when you look at your SAR reports. This was generated with KSAR. But once again, you just don't want it to go so deep that there's going to be lag behind when your CPUs are in such a deep sleep and HANA needs to utilize the power of that CPU. All right, so I talked a little bit about hyper-threading. The first thing to know about hyper-threading is on most SAP systems, it's a good thing. It does increase performance because, once again, we're able to get more execution contexts, right? Versus just threading in the OS, right, or at the application level, we're actually getting that down to the CPU. So typically that's a good thing. Now there's two issues that you need to be aware of when you're looking at large systems. One is the number of sockets. So there are SAP notes that talk about that if you have more than 8 CPUs, unless it's on the certified list, you need to disable hyper-threading, okay? The other thing is that for your application, your OL AP, you can go above 1,000, but for HANA right now, the limit is 1,000. And that's a HANA thing. So, for example, on some of the Azure instances I've worked with my customers, for the NetWeaver stack, we can actually have up to like 1,700 CPUs. But that hyper-threading has to be disabled for the HANA stack because it's 800 and 32 or whatever it may be, and we can't go over 1,000. So that's one of the things that you want to be aware of. All right. So I mentioned that HANA is smart enough. It's NUMA aware. It's going to be probably, when you look at like the interleaving, when I showed you that NUMA stat, you saw the interleaving, that it's going to be managing NUMA and balancing that across the different NUMA nodes. So if HANA is so smart, then why do I need to worry about? Well, one's going to be understanding my workloads, and also you probably won't need to worry about tuning any NUMA and looking at some of these things until you start utilizing at least 50% of your memory. Before that, unless you really have some specific workload that's intensive, you shouldn't need to worry about it. The other thing that you'd probably need to look at is, why are you running such a large system? I know some customers, they go to a large system like this not because they need the memory, but they need the CPUs. But maybe the offering for that instance type says, well, you got to get at least 12 gig of memory to get 800 CPUs or something like that. So understanding why and what your workload is key there. I mentioned that looking at some NUMA nodes and are really busy and others are not. Well, what are those thresholds? Well, typically when you see that, you're looking about if it's 80 or above on one and below 10 on another, then that's telling you, hey, something's wrong. Now, HANA does allow you to pin jobs to specific NUMA nodes, and maybe that's the way to go, but I would definitely, before you start going that route, make sure you understand why you're doing that and if there's other alternatives. Also, to kind of wrap up NUMA, a couple of things here. Sub-NUMA clustering is not supported. In fact, you'll probably corrupt your database. And so there are, like some Linux tricks that you can do things. You could say like, okay, so typically a NUMA node is a socket, right? So if I have a 16 socket, I probably have 16 NUMA nodes. Well, you can subdivide a NUMA node. You can say like NUMA node sub is really just CPUs, 0 through 15, and then NUMA node is 16 through 32, that kind of thing. That's not supported with HANA because, once again, it's NUMA aware. It's reading the NUMA topology of your environment, and so you want to make sure you understand that HANA is doing that. We're not going to go against that. One other thing I want to bring up on this is I showed you in the beginning, right? We had some virtual instances. We also had a bare metal instance. This is, and when I worked with my customer, we were actual virtual instances, right? We're on Hyper-V in the Azure cloud. And so these things do matter as you are configuring your environment. Okay. The reason why I'm kind of bringing this up is because now let's talk about maybe some scenarios and some symptoms you might see. So we're looking at our pacemaker log, and we're seeing some HANA calls. In fact, I'm probably looking at this because I probably had a failover. I got a fenced node on here. And so working with my customer, they give me a call. They say, hey, this node's getting fenced. Can you look into this? So we start looking at this, and we're like, HANA call, okay. Well, we need to understand that HANA call is actually calling some scripts, some Python scripts, and this is part of the topology resource agent for our environment. Well, okay, so we're looking at this. We're saying, okay, I've got a 24 terabyte database. I'm getting these timeouts on the topology. Looks like I probably need to update my cluster timeouts, right? Maybe my monitoring settings and things like that. Well, we started looking at that, and that's not the direction you want to go. So what's surprising, and I'm curious if anyone has any other scenarios, but talking to my other colleagues in support is typically the cluster settings, for the most part, you're not going to change them very often. Even for 12, 24 terabytes, whatever they may be, databases, the cluster itself is going to handle those pretty well. And so looking at whatever the documentation for like what the cloud provider might have for setting things up, what SAP might have, following the SUSE docs, you probably want to stick with those and not change it, because as we looked at our environment, this is what was important to look at. Why are we getting timeouts? Well, a lot of this topology is dependent on infrastructure. So we started looking at, like in the Azure portal, are we getting any drop packets? Are there network issues? What's going on with NFS, right? We looked at SAR reports, our NFS, our RPC calls, those kinds of things. And we didn't find any errors. But what we did find is that in Azure, for these ANF volumes that we had, to get a certain bandwidth, you had to buy so much storage. So even though they said, we only need 50 terabytes, they said, well, 50 terabytes, and I can't remember what it was at the time, but 50 terabytes might only give you 5 gig of network bandwidth. If you want a full 10 gig, then you got to buy 100 terabytes, even though they didn't need the space. Well, once we addressed those issues and we got the full bandwidth, guess what? These went away. So it's not that we were getting errors, we just didn't have enough bandwidth for those to respond accurately. So if you think that, hey, there might be some issue or I might be experiencing latency, one of the things you can look at is this HANA call timer. Has anyone ever used HANA call timer? Okay. So you can go to this Git repo. It was actually written by one of our premium engineers. And what it does is it makes a system replication status and a landscape host configuration call, and then it calculates the latency, okay? And so and the nice thing about this is it creates just a simple, it runs as a systemd service, and then it creates a simple CSV output, and you're looking at what the milliseconds were for that to happen. And so if you're going along and you're like, okay, 200 milliseconds, that's pretty good. 300 I can live with, right? Okay, whoa, now I'm like 50 seconds on here, right? And so that's when you start looking at this. There's another utility that you'll see floating out there, and that's a HANA call strace. Anyone use this one? Okay. I'm actually glad to hear that, because that means, well, it probably means you haven't run into too many issues at this level. But when you run this, the nice thing about this is that it will actually show you the calls that are being made. Okay? There's trade-offs. My recommendation and my experience is start here and see if you're seeing any actual utilization for these calls, if you're starting to see timeouts in your log. Then this can help you track it down. I wouldn't start here, because just playing around with it, because these are ugly. If you just do a Python print command, you're going to have over 800 lines of strace calls. Plus, you do have to have strace installed, and I know a lot of times that's not desired for a production environment. So, but this is where you might actually see what's happening. Here's an example, kind of what that, for your SID admin, and then it's cut off here, but you would see what's being called, and then you could look and see where is it waiting on a specific call for that to happen. Another way you can look at your environment is to use NFS IOstat. And in addition to, so you're going to look at, when you do this, you're going to see each one of those NFS mounts on there. And in addition to, just your standard ops and your, how much bandwidth is being transmitted. A couple of things real quick. It's easy to look to see, are there any errors on the network, right? Are you getting any retransmissions on there? A lot of times I think this is a little easier to look at than looking at your SAR reports, because those can be lengthy. The one thing that SAR reports are going to give you, though, is usually you're going to schedule those to run every so often. My customer has those running every 10 minutes. However, we've changed that says, hey, if we start getting certain thresholds after 10 minutes, then we start running the SAR every minute, so that we can get more to pinpoint that. But I like to go here first just to say, hey, are there any retransmits? Okay, and then we look at the round trip time. Okay, so round trip time is where we're looking at latency. So from when the RPC call was made, how long did we get a response back? Now, if we look at this round trip time, we're looking at 20 milliseconds, but then we have this average execution time. Well, the RTT is actually, that 20 seconds is part of that 732. So this is what was transmitted. However, when we look at the amount of data, that's how long it took to execute on that. So this is typically okay, just because that's workload, and also if you understand RPC, that it can put multiple calls into the same packet or payload on the other end, so that's okay. That's why typically we're looking at the RTT for latency for our ANF or NFS mounts. The other thing we want to look at is, what are we measuring? Are we trying to measure bandwidth? Or are we trying to measure latency on there? And so to do that, one of the things that we've found that works best is to actually use FIO. And when we're doing FIO, what we're doing is we're saying we want to write a file to that mount. So we have the command, we're going to do that. That's going to be in this configuration, and there's some sample configuration to start with. It's pretty easy to do. And we actually just had to write a single file to that. And that helped us understand our latency. Now, the other thing you can do is you can say, okay, way back when I talked about pinning, right? Before you're deciding, hey, do I want to pin my network stack to the NUMA node of where that network interface is attached? Well, we can test that out, okay? When we do this, now we're going to use task set, and we're going to say, okay, I want to run some type of workload on CPUs 10 through 45. So typically you don't want to do 0 because you want to save that for your OS. But usually something greater than 10, we did 10 to 45, and we run this. Now, on here, we know that this was NUMA node 1. We know the network interface was on there. And so now, when we come here, we can look at our latency on here. We ran that same workload on CPUs 729 to 771, and we saw that it did take us longer that we had. When we take a look at our number of writes on here, we saw that there was a difference as far as how much megabits got written there. So this is a great utility to see how your NFS mounts are performing, looking at in addition to your I/O stats. Also looking at the HCMT. How many people are using HCMT or have used it? Okay. So a lot of times you don't need to because we're maybe taking the word of whoever certified it, right? We're trusting SAP and that platform, whether it's a cloud provider or bare metal. But if you want to test and get your numbers, one of the things we were looking at was this was actually testing a new instance type that Azure was coming out with. So it actually had not been certified yet, so we were using the HCMT from SAP to run these tests. And so one of the things that we were looking at here is looking at the performance, right? And so here you say, okay, here's the KPI, which we're looking at. What are we measuring? Well, throughput. And we want to take a look at, what values it would be in, and then whether it actually met that threshold. And so this is a tool that you can use a lot of times to say, okay, well, we were told we were supposed to get this type of performance. Are we getting that type of performance? And so one couple of things about this is it actually, I think it works pretty well. It seems like it's a pretty good tool. The one thing that we did run into is just understand that it's not your workload. So when we tested this, we brought this new instance, we put the workload on it. It seemed to behave pretty well. It seemed to perform well. We ran the HCMT on there, and it failed. We're like, wait a minute, what's going on? Well, it's because we had multiple NICs that were accelerated, and we were pinning workloads. And so in our situation, the HCMT failed because we pinned some workloads and not other workloads. Once we pinned all the workloads that we had expected to the different, because we had a management network and some of these other things. So we didn't figure the management network mattered, right? Well, it caused HCMT to fail. But it's another tool to look at as you're measuring these things. So as you're looking at your environment, there are some HANA call, there's some tips about customizing this, but I really would hesitate changing those thresholds before you do that. Make sure you understand what you're measuring and how you're going to manage this, and what are those KPIs that you're looking at. There's something else I was thinking about, but the one thing I would also say is the customer I work with, I like I said, I'm the dedicated support engineer from SUSE. They have one from Azure. They also have their support agreement with SAP. And one of the best things that our customer did is they brought us all on site for a week. And and they said, look, we don't want SAP saying one thing and SUSE saying another, right? That kind of, and get around those things. So we want you guys to work together. Well, I have a great relationship with my Azure counterpart, and a lot of times we, before we even get on with our customer, we get on together. We're saying, hey, I'm going to recommend this. What does Azure say? And it's funny because there was one time like SAP made a recommendation, SUSE was on board, we made the recommendation, we agreed with it. So Azure, SAP, SUSE all said. We get on there, the customer says no. We said, well, hey, your three vendors are saying we strongly recommend this. Okay, well we'll throw it in a lab, we'll test it, and it was good. And I'm not throwing my customer under because there was some good caution, and we're actually not going to implement it yet, but we will probably implement it later on. There were some good things we learned. So I would definitely collaborate, definitely work with everybody. Each vendor has their skill sets, and like I said, mine just happens to be with Azure, but I know there's a lot of other great cloud providers out there. Make sure you understand what you're measuring. Like I said, there were times that someone might have been measuring, they think they're measuring like performance in a matter of bandwidth, but really they were concerned about latency. And so make sure you have the right tool for that. Here's some other sessions you can take a look at. And thanks for being here. Enjoy SUSECon.